Dear students, in the last class we have completed the chemical properties of alcohols. Now we will go on to some commercial important alcohols such as methanol and ethanol, their preparation and some uses of methanol and ethanol. First we will go for methanol, or it's also called methyl alcohol. Methanol is also known as wood spirit, was produced by destructive distillation of wood. Since it is extracted from wood, it's also called as wood spirit. Remember, methanol, it's also called as what? Wood spirit. Today, most of the methanol is produced by a catalytic hydrogenation of carbon monoxide at high pressure and temperature in the presence of zinc oxide and chromium oxide catalyst. Remember, methanol is produced by catalytic hydrogenation, catalytic hydrogenation of carbon monoxide, catalytic hydrogenation of carbon monoxide at high pressure and temperature in the presence of catalyst. Which catalyst? Zinc oxide, chromium oxide catalyst is used. The carbon monoxide, it is hydrogenated, that means addition of hydrogen in the presence of catalyst. Which catalyst? Zinc oxide, chromium oxide catalyst, and at 200 to 300 atmospheric pressure, 200 to 300 atmospheric pressure, methanol is formed. Methanol is formed. This is the simple method of preparation of methanol when carbon monoxide is hydrogenated in the presence of zinc oxide, chromium oxide catalyst at 200 to 300 atmospheric pressure. Methanol is formed. Methanol is formed. It's highly poisonous in nature. It's a traces or small quantity of methanol causes blindness, and when it is in excess or large quantities causes even death also, even death. Methanol is used as a solvent in paints, especially in the manufacture of paints, varnishes, and chiefly for making formaldehyde, chiefly for making formaldehyde. Then the second compound is ethanol or ethyl alcohol. Ethanol is obtained commercially by fermentation method. That is especially the fermentation of sugars. The oldest method was preparation of ethyl alcohol from sugars by fermentation. What? Sugar in molasses, especially sugar cane, or fruits such as grapes is converted into glucose and fructose. Remember, both have the same molecular formula of C6H12O6 in the presence of enzyme invertase or invertase enzyme. You know, sugar means what? C12H22O11 is a sugar. When it is treated with the enzyme invertase, which decompose into glucose and fructose. Say, sugar, when it is with water in the presence of invertase enzyme, which converts into glucose and fructose. Once we get glucose and fructose, they undergo fermentation in the presence of another enzyme, zymase, which is present in the yeast, which is present in the yeast. It is glucose or fructose, which in the presence of enzyme zymase, which converts into alcohol and carbon dioxide. The resulting alcohol, that is ethyl alcohol, is formed. This is the manufacture of the ethanol. Remember, when sugar cane juice or sugar, when it reacts with water in the presence of invertase enzyme, which converts glucose and fructose, which is in the presence of zymase, which gives ethyl alcohol. that means glucose or fructose in the presence of zymase gives ethyl alcohol with the evaluation of carbon dioxide. Remember, the reaction must be carried out in the absence of air. In the absence of air. Here, how this forms: when grapes are crushed, sugar and enzyme come into contact and fermentation starts. This is what I said. Fermentation takes place in anaerobic condition, nothing but what? In the absence of air. So what would happen if there is an air? That is, the alcohol present formed here by zymase enzyme, which converts into carboxylic acid. That means once we have the condition of uh, oxygen, that means air is present, then the resulting alcohol which oxidizes to ethanoic acid, which changes the taste of drink. That means ethyl alcohol's taste changes. It is a colorless liquid with boiling point 351 Kelvin. It's a colorless liquid. It is used as a solvent in paint industry and in the preparation of a number of carbon compounds. Preparation of number of carbon compounds. Commercially, alcohol is made unfit. Remember, the alcohol which is formed here, which is used for drinking purpose or from other purpose, which can be made unfit. That means which is not suitable for drinking. Can be done. How? By adding copper sulfate to it. That means when pure ethyl alcohol is there, when you add copper sulfate, its color changes and it is unfit for drinking. Unfit for drinking. The same unfit for drinking can also be done by pyridine, by adding pyridine, which gives foul smelling, and copper sulfate gives what? Color. That's what alcohol, commercial alcohol form, which is made unfit for drinking by mixing in it with some copper sulfate and pyridine. Copper sulfate gives color, pyridine gives a foul smell. That process is called as denaturation of alcohol. That is called denaturation of alcohol. Remember, denaturation of alcohol means the alcohol which is made unfit for drinking purpose by adding copper sulfate and pyridine. Copper sulfate and pyridine. So that's about the alcohols. That's about the alcohols. Now we'll move on to the another compound, phenols. Already studied or said in the beginning, phenols are the compounds. That means when the benzene ring or aromatic hydrocarbon, one of the hydrogen atoms of aromatic hydrocarbon is replaced by OH group, which results in phenol. Remember, one of the hydrogen atoms of the aromatic hydrocarbons replaced by OH group, hydroxyl group, which results in what? Phenols, which results in phenol. On the basis, that means the number of OH group directly attached to the benzene ring. Remember, here OH group must be on the benzene ring, but it should not be on the side chain. If suppose OH group is present on the side chain with the ring, then it belongs to alcohols. If OH group directly attached to the aromatic ring, like the benzene or some other aromatic ring, then only that is called as what? Phenol. That's called phenol. On the basis of number of OH group, whether that only one OH group is attached, 2, 3, they are classified into mono, di, and trihydric phenols. Mono, di, and trihydric phenols. We'll go one by one. Monohydric phenol. So what does it mean? The aromatic ring which contains only one OH group directly attached to the ring, or benzene ring in which only one OH group directly attached, then that is called monohydric phenol. Phenol contain only one OH group that directly attached to benzene ring. So this is phenol. Cresols. Number of examples we can give. It's a cresol. Since CH3 position present at meta, therefore it is called a metacresol. Say if it is present at para position, then it is called paracresol. Similarly, orthocresol present at ortho position. All these examples they have only one OH. That's why these are called monohydric phenols. Other second dihydric phenol. By the name itself, one can say, and you are able to say now what is dihydric phenol? A benzene ring in which two OH groups are attached. Two OH groups are attached are called dihydric phenols, or phenols which contain two OH groups directly attached to benzene ring. You can see the two OH groups are attached here, therefore it is dihydric, and they are adjacent to each other, therefore that is called catechol. Here two OH groups are present, but they are present at one and third position, that's why it is called as resorcinol. If they are present opposite, there is nothing but para position. Therefore, it is called phenol or also called hydroquinone. Either it's called phenol or hydroquinone. Now, the last category here is trihydric phenol. Trihydric means what? Three OH groups are attached directly to the benzene ring. Three OH groups are attached directly to the benzene ring are called as trihydric phenols. Trihydric phenols. Three OH group. So pyrogenol. 1, 2, 3. Position 1, 2, 3. Therefore, it is called 1, 2, 3 trihydric benzene. Trihydroxy benzene 1, 2, 3. Trihydroxybenzene. This is 1, 2, 3, 4, 5, 6. Positions are 1, 2, 3. Therefore, 1, 3, 5. 1, 3, 5 trihydric or trihydroxybenzene. Common name is fluorobutanol. Here 1, 2, 3, 4. Positions are 1, 2, 3, 4. Therefore, 1, 2, 4 trihydroxybenzene. Trihydroxybenzene. These are the example for trihydric phenols since they contain three OH group directly attached to the benzene ring. Next, we can move on to the preparation of phenols. How phenols are prepared. First one from haloarenes. What is the meaning of haloarene? You might have studied this in haloalkanes and haloarenes. Halogen group such as chlorine, bromine, iodine or fluorine directly attached to the benzene ring are called as haloarenes. From such compounds we can prepare phenols. How? Example, chlorobenzene is fused with sodium hydroxide. Chlorobenzene is fused with sodium hydroxide. Sodium phenate is formed. That means chlorine substituted by ONA, sodium phenate is formed, which is acidified with HCl. Phenol is formed. Simple. It is haloarene, nothing but chlorobenzene. When it is treated with the sodium hydroxide, here this is Cl minus, and here the group is NaO. This is H plus and ONA. This ONA substitute in the place of what? Chlorine. Therefore, which results in uh, sodium phenate. Sodium phenate at 623 Kelvin and 300 atmospheric pressure. Sodium phenate is formed. Now our target is to remove what? To remove Na, and we have to place what? H. What can be done? HCl you can add. Cl combines with the Na and which goes out, and H combines with O converts into what? Phenol. Hence phenol is formed. Phenol is formed. Okay. Repeat. Chlorobenzene treated with the sodium hydroxide at 623 Kelvin and 300 atmospheric pressure. Sodium phenate is formed, which is on acidification with HCl gives phenol. Use phenol. Second method, from benzene sulfonic acid. Word says benzene, so there must be benzene. Sulfonic acid, SO3H. That means SO3H group is directly attached to benzene called benzene sulfonic acid. Benzene is sulfonated with oleum. Benzene sulfonic acid is formed, which is converted into sodium phenoxide on heating with the NaOH. Once we get sodium phenoxide, very simple. Acidify with what? Some acid, commonly HCl is used. Acidified with HCl, use phenol. Say benzene treated with oleum. Oleum means you might have studied in the first previous in P block element H2S2O7. It is called oleum. When benzene is treated with the oleum, benzene sulfonic acid is formed. That's what I said. Benzene ring with SO3H group is called sulfonic acid directly attached to the benzene. Therefore, it is called benzene sulfonic acid, which is treated with sodium hydroxide. This SO3H group substituted by ONA and converts into sodium phenate, which gives what sodium phenate. Further acidify with HCl, that means in acid medium, gives what phenol. Remember, first step it is treated sodium phenate. Sodium, this ONA group substitutes with what? SO3H gives benzene ring with ONA. Next, second step on acidification. On acidification, H plus is added, the phenol is formed. Now, the benzene diazonium salt with the benzene ring. A diazonium salt is formed by treating an aromatic amine such as aniline, with nitrous acid. What is nitrous acid? HNO2. How it is formed? By combination of sodium nitrite with HCl. Sodium nitrite with the hydrochloric acid at 273 to 278 Kelvin. Once we get diazonium salt or benzene diazonium salt, which is hydrolyzed, nothing but water is added to phenols by warming the water with water or by dilute acids. Say aniline, aromatic amine, treated with the sodium nitrite and HCl, nothing but what? Nitrous acid, which gives the benzene. So you can see this is benzene. Di means two. Azo means nitrogen. Em means positive charge. Chloride, Cl minus. Therefore, benzene, diazonium chloride. How to remember? Simply we can use a trick to remember here. Benzene, di means two, azo means nitrogen, em means positive, chloride means negative. Therefore, benzene diazonium chloride is formed when aniline is treated with the nitrous acid or sodium nitrite in HCl. Once we get benzene diazonium chloride, which is hydrolyzed, nothing but what? Water is added. What would happen? Here, nitrogen gas escapes with the formation of phenol. Dinitrogen is formed as well as HCl is formed. So this is the preparation of phenol from diazonium salts. Remember, when aromatic amines such as aniline treated with the nitrous acid, sodium nitrite in the presence of HCl, benzene diazonium chloride is formed, which is on hydrolysis gives phenol. Now the next method is from cumene. What is cumene? Cumene is also called as isopropyl benzene. It's also called as what? Isopropyl benzene. Who took? It is cumene is oxidized in the presence of air to give cumene hydroperoxide. It is converted to phenol and acetone by treating with dilute acid. So this is cumene. It's also called isopropyl benzene. Why means benzene ring is present at iso, therefore it's isopropyl. When it is oxidized, this is cumene, is oxidized, addition of oxygen. This oxygen attacks the CH position and forms cumene hydroperoxide. You can see this is called cumene as usual, and this is two oxygens are attached here, therefore cumene hydroperoxide. Now it's just heated or warm. After heating in the presence of acid medium, this entire acetone is removed with the formation of what? Phenol. With formation phenol is formed and side product is acetone is also formed. So remember, when cumin is oxidized, cumin hydroperoxide is formed, which is on hydrolysis in the presence of acid medium, phenol is formed. Now its physical properties. Phenol is colorless liquid or crystalline solid. On exposure to air, it turns to red due to formation of phenol. Means it undergoes oxidation. It is sparingly soluble in water but completely soluble in organic solvent. Sparingly soluble in water. It is highly corrosive and causes blisters when fall on skin. That means a drop of phenol on skin causes blisters. A liquid form of phenol containing 5% of water is called carbolic acid. Say it's important for one mark question. Carbolic acid. What is carbolic acid? Carbolic acid is nothing but 5% of water of phenol. That means a phenol containing 5% of water. Phenol containing 5% of water is called carbolic acid, or 95% of phenol is called carbolic acid. The boiling points of phenol increase with increase in the number of carbon atoms because increase in the van der Waals forces. The OH group phenols is involved in intermolecular hydrogen bond. Here phenol also which undergoes intermolecular hydrogen bond. The boiling points of phenol are higher in comparison to other class of compound, namely hydrocarbons with the almost same molecular formula, ethers, haloalkanes, haloarenes of comparable molecular mass. That's what I've said. The molecular mass of the phenol which we are going to consider and which is compared with either other hydrocarbons or ethers or haloalkanes, their boiling point when we compare, the boiling point of phenols are greater because phenols form intermolecular hydrogen bond. Due to intermolecular hydrogen bond, force of attraction is strong, they have high boiling point, but that type of intermolecular uh, hydrogen bond is absent in hydrocarbons and in ethers. For example, ethanol and propane have comparable molecular mass, but their boiling point differ widely. Boiling point of methoxyethane is intermediate of the two boiling point. It was explained while explaining in ethanol. Next, we can move on to the solubility of phenol. Phenol's solubility of phenol in water is due to their ability to form hydrogen bond with water molecules. Remember, phenol, though but the solubility of phenol is less in water. That solubility, whatever may be the percentage of solubility of phenol in water, that is due to the formation of hydrogen bond because phenol readily forms hydrogen bond with the water. Solubility decreases with increase in the size of alkyl or aryl groups. Several of lower molecular mass alcohols are miscible with water in all proportion.